Tropical rainforests are among the most biodiverse ecosystems on Earth. They used to cover most of the equatorial lowlands of South America, Africa, Southeast Asia, New Guinea and Madagascar. Unfortunately, since the 1970s, evergreen tropical rainforests have been rapidly decreasing in area. Biodiversity loss is advancing at an accelerating pace in all tropical rainforests. Rainforests are normally tall and structurally complex evergreen forests that form the natural vegetation cover of the wet tropics. The climate of the wet tropics is mostly very warm and the dry season is either short or absent. About half of the world's tropical rainforests are located in Central and South America. The second largest rainforest block grows in Africa, especially in the close vicinity of the Congo River basin. The third largest area of tropical rainforest is occupying Southeast Asia, New Guinea and Australia. However, most of these rainforests have been heavily degraded during the last decades. The fourth largest block of tropical rainforest covers the island of Madagascar. Unfortunately, most of the Malagasy rainforests have already been destroyed. Amazonia comprises the world's largest tropical rainforest, which makes it of paramount importance for regulating the global climate, maintaining biodiversity and providing ecosystem services, as well as many timber and non-timber products. Ranging from the Andes in the west to the Atlantic Ocean in the east, Amazonia covers an area larger than the European Union and spreads over 9 countries. It has been estimated that the Amazonian forest harbor more than 10% of all the species in the world and 25% of all global terrestrial biodiversity, with more than 15,000 species of trees. A single hectare of Amazonia can contain over 300 tree species, more than all of Europe. The researchers of the University of Turku have studied the biodiversity and ecology of Amazonia since the 1980s. For example, I'm studying the diversity of Amazonian insects. During the last 20 years, we have discovered, for example, hundreds of unknown wasp species from Western Amazonia and tropical Andes. Amazonia is also of utmost importance in safeguarding cultural diversity. Amazonia is home to millions of people, many of whom live in remote areas in villages and communities along the rivers. It has been estimated that the indigenous people of Amazonia speak over 300 languages, representing 15 or more language families. A sustainable future for the tropical rainforest and their inhabitants is crucial for the global well-being. It is most important to remember that all rainforests are different and they all maintain unique biodiversity and cultural diversity. Thus, the goal should be in saving as many rainforests as possible in different areas of the equatorial region.
Okay, so as you have already heard, Amazonia is the largest rainforest area in the world. And often it's thought like it's a big carpet of just uniform rainforest, but that's not actually true. Amazonia is very heterogeneous, and it has a huge variety of different kinds of vegetation types. And these range from forests that get inundated by rivers when it's the annual rainy season, they're even wetter than the other parts of the year, and forests that are not even completely tall forests because they grow on very poor soils and become just like small shrublands. And one way how we can look at this variety of forest types at the continental scale is by using remote sensing. Especially satellite images are very useful because we get an overview even over areas that we cannot visit because they are too remote and too difficult to get to. And we have in the background here one satellite image composite based on Landsat satellites that we have produced here in the University of Turku. Our team has been working on this for a long time. That shows this kind of variation in the rainforests as color differences over the rainforest area. And we have also used this information to propose a subdivision of Amazonia so that from the local scale variation that you can see in the satellite images, we get to a continent-wide classification of the rainforest into ecologically or geologically or biogeographically different kinds of units. And those can be seen with pretty bright colors in the satellite image here. And that is very important knowledge, because then when we understand how the rainforest varies, we also can see where things are unique. There are things that are only distributed in part of the rainforest area. Some species have very narrow ranges. Some vegetation types are unique to one part of Amazonia. And that can be very important consideration when we think about the conservation of biodiversity. One problem that all rainforest areas and nature in general is facing is conversion by people to other uses. So forest is converted to something that is not forest. And here we have the same satellite image composite that we had before, and now there's in yellow indicated those areas that have already been converted to something else. So it used to be forest, but it's no longer forest. The bluish pale areas are areas that have never been forests. So they are montane ecosystems, they are savannas, they are big swamps, they are areas that have some kind of other vegetation but not forest. But the yellow is the area that has been converted from forest to something else. And the greens and browns, they are the areas that are still forest. So the majority of Amazonian forest is still there, but the conversion to something else has been pretty alarming. And it's very regionally focused. So we see that in southern part of Amazonia and in the eastern part of Amazonia, that's where the deforestation has been most destructive, and that's where the biodiversity is most affected. And this is where this kind of regional understanding on how the biodiversity is distributed, where do we have unique species, where do we have unique habitats, and how do these different things link together? That's where that kind of understanding is especially important, because then we can focus conservation efforts and look into alternative ways of dealing with the biodiversity, targeted in such a way that we have some understanding on what is there and what are the areas that are most endangered and unique, where we should focus on. And we often think that the main threat for Amazonia is timber, and that has been traditionally an important issue. So there is very valuable timber in the tropical forests that gets logged, and those timber resources have dwindled in many places. But often there is still some forest left after the important timber has been taken away. Pulp production is a problem because that destroys basically the entire forest. And pulp production often is done with plantations, which are often non-native species, which can be another problem. And then we have some industrial kinds of systems. So for example, mining can be very destructive, and even hydroelectric dams, which we think hydroelectricity is an environmentally friendly way of producing electricity. But in Amazonia, which is very flat, the dams, they cause flooding of huge areas, and then we get drowned forests and methane emissions. So whether that's environmentally friendly or not can be debated. But in the Amazonian context, the biggest threat to the rainforest is our meat consumption. Because most of the forest, when it gets converted to something, it gets converted to cattle pasture to produce beef. And much of that beef is exported to the rich Western countries. And another big thing is soybean plantations. And they are also mostly produced for fodder for cattle and pigs outside the tropics. So the North American and European animals, they are, to a large degree, they get fodder from the rainforests that have been converted to cultivated fields. So that is something that links this deforestation in Amazonia to our everyday lives. The more meat we consume, the worse the situation for Amazonia, because that is where the demand is satisfied from. And much of the conversion of forest to agricultural land is done by burning. So the forest is first cut, then it's burned, and then we get the cattle or cultivation instead. And of course, burning is a very effective way of cleaning the land, but it's also very destructive in terms of climate impacts, because all the carbon that used to be stored in the forest in burning, it gets freed into the atmosphere and contributes to climate warming. And climate change is another big threat to the Amazonian rainforests and to other areas in the world as well, because the prognosis is that Amazonian climate is going to become drier and warmer at the same time, which means that wildfires become more common, and fires can spread to areas where they never occurred before, where the plants have no resistance to fire, where the fire simply kills more than it would in areas where they are more used to that. And there is a big, big concern that Amazonia is on the way of becoming savanna. We use the term savannization to this system where something that used to be a wet climate that supports forest, because of the climate change and the increased fire occurrence, actually becomes drier and is converted into a savanna. Now, we have been doing a lot of research on the components of the natural forest in order to understand how they work, how they function, what kind of things we have there, what is the biodiversity that is there. And in this process, it has become clear that when you do field work, you often find species that were not known. You realize that something that was thought to be one species actually isn't, that it's instead of being one widespread species, it may be actually 6, for example, much more narrowly distributed species. This is what we see in this slide here, which exemplifies one fern genus that we have been working on, and that one, everybody thought it's just one species. But then in the field, when we were doing this ecological research in Amazonian rainforests, we realized that there must be more than one. And now it turns out that it's 6. 4 of those have now been described as new species. And we see that there is more heterogeneity in Amazonia, more variation between different places than we thought, which is very, very interesting. But it also raises concerns that these species that we thought they will always survive somewhere else, maybe they don't, because maybe their distributions are more limited than we thought. And even though we have all these wonderful tools that make it possible to do remote studies, we have satellite imagery and other ways of looking at things from far away, we still need to go into the field in order to see what is really there, to see all that wonderful diversity, and to document what is there. And that is a kind of modern day explorations that we have been doing, trying to get to those places where we still can see the pristine rainforest in order to understand what is there and how these forests function. And those, the documentation, the specimens that are collected, they are stored and they will be used by future generations of researchers. And we are taking advantage of all the history of explorations that have been done in those areas before in order to understand the ecology of the rainforests, the biogeography of the rainforests, how they function, how they probably would react to environmental changes of different kinds, and how that diversity originated in the first place. So these rainforests, they are wonderfully diverse, intriguing, scientifically interesting question that is certainly worth our attention and worth being protected for the future.